Good morning. Today we have a very powerful topic that can determine whether you're going to like physics, dynamic physics, or whether you are going to basically hate it. This is an important topic that many people get confused in. And so what I'm going to try to do in this video is to try to make this as simple, as intuitive, as logical as humanly possible. This lesson is all about understanding the things that go on. So without further ado, let's see the shape that we have in front of us. So we have a ball, projectile, basically an object that doesn't have any source of propulsion. So it is launched from here, and the impact site is here. And so this is the path, the trajectory. Okay, this is the trajectory of its motion. So this is the highest point. Well, it may not look like so from my drawing, but this is the highest point. And this area is equal to this area. And the ball went right over here, reached this area, and impacted here. So what's the point? Now, one thing you have to understand is that in any horizontal line like from here, or from here, or from here. So the speed in this area, in this point, will equal the speed at this point. And the speed here, exactly the same. But the velocity will not be the same. The absolute value of velocity will be the same. Because velocity, if you remember, we have directions, we have positive, we have negative, and so you will get the same value, the same magnitude for velocity here as you will here, but here you will have a positive and here you will have a negative value. So that's it for now. You got this is equal to that. Here, no, this is a misconception people get. The velocity here is not equal to 0. Okay, so the object goes right over here, continues. No, the velocity here, there is a velocity right over here, by the way. This object will never stop in any point. Well, when do we get velocity equal to 0? If you get a ball, and so this is a separate example, for example, okay? So if you have a ball, and you bring this ball, and you throw it up, and it falls down, it will stop at the very outermost edge. The velocity will be 0. But this will not happen in our case. This is a big misconception you have cleared out. So what happens in terms of velocity? So we will call this VI, okay? And we will call this VF, okay? VI, VF. Now, a big misconception people get is they want to work with the real velocity. That is wrong. Now, what do I mean? Now, at any point here, the velocity, in this point, for example, the velocity is pointing here. And here, the velocity is pointing in this direction. It's tangent to the curve. So, for example, we have the velocity, it's pointing in this direction. That is where the real velocity. We can bring the components, and this is the only way to work in projectile motion problems. You have to bring the components of the real velocity. And so how do I bring the components? Well, the components have components x and y. So we are going to create components like this. And so this is the resultant, and we just drew out the components. Now, why did I draw the components? Well, we are going to be analyzing the velocity of the projectile in terms of components only, and we will ignore the resultant. So, is there any point I would like to mention? We will call this V, and this will be Vx, and this Vy. And we can actually bring the components of this velocity point right over here. And so this will have Vx and Vy, but I will call it Vix because it's Vi. So I'll call it Vix, the x-axis right over here, and this I will call Viy. And in this point, we have, it is pointing like that. We have VFX, and we don't have any y. The y is 0, so it will be VFY, which is essentially 0. And so we have the components, and we understood how we label them. So let's take some rules. Well, the first rule says, and this is intuitive, so you have to get it. The x component of velocity never changes. So here we have Vix is equal to Vfx. And so the x component in every point of velocity, here, 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 is similar. It does not change. Now, the y component of velocity in this point, in this point, in this point, look, you have Viy, and then you have Vy, and then you have Vfy. What's happening? This is 0, and this exists, and this exists. We understand that the y component of the velocity in any point will decrease as the object is climbing. And that makes great sense. You know, you have an object that you throw in the air, it will decrease its speed, and then it will increase it back again, but only in the up direction. Okay? Only in the upwards direction. So we have an acceleration that is acting on the y components. So at first, Viy was big, it became smaller, and here it became, if we have velocity vector here, it became smaller, 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 until it reaches 0. Okay? So we have an acceleration acting vertically on the object, on the axis Vy. So the acceleration is negative. It keeps working until it makes Vy 0, as we have Vfy is in this point is 0. Okay, and then it becomes negative. It keeps it negative until we have the horizontal component. Excuse me. The vertical component starts to increase back again. So let's get to our rules. So what do the rules say? Well, the rules say something very important. So now that we understand this, we know that the 3 laws of motion are Vf equals Vi plus At, and D is equal to Vit plus half At squared, and Vf squared is equal to Vi squared plus 2Ad. We can't use these rules in projectile motion unless we are acting on a component. So let's say we have a ball. So we're just going to take this simple and easy example, and we threw the ball from here to here. These are on the same plane, and the ball, the Vi is 30 meters per second. Okay, and it was launched at 30 degrees from the x-axis. So we're going to understand this exactly right now. What we want to know is the time it takes for the ball to complete its trajectory. And so in order to solve this problem, we need to find the time it takes in order to reach from here just to here. And then we will multiply, because it takes the same time to go from the ground to up and from up to down. So we know here Vf, we'll call this Vf, and then we'll call this Vi. So Vi is equal to 30 meters per second. And so this is a very bad drawing. So let's complete Vi here. So we have, this is vector Vi, it's equal 30, and we will draw components. So the component x and component y. And so we'll call this Vix and Viy. And so what is Vix and Viy? And will we need them? Well, the answer is yes, you will need them. Now we understand that the Viy will decrease here, decrease until it reaches 0. So we will use the first law and adapt it to projectile motion. So see how this works. Do you see the subscripts right over here? I'm just going to put y next to each one. So I have VFY equal VIY plus AYT. And T, of course, doesn't have a subscript. So let's see how this will turn out. We have final velocity y, and so we have VEF x and VFY is 0. So that will be 0 equal VIY. Now VIY, we need this. How will we bring the number of this? Well, we know the rule to bring the components. And so the rule says, just in case you don't know it, if we have theta here, okay, this is 30. And we have a theta, which is just an angle. If you need to bring this, you bring 30 times cosine of theta. And if you need this component right over here, you say, 30 times sine of theta. That's the simple rule without going into how we brought it in. We can make another video about how that comes to happen. But we need VIY. So we'll say sine theta. We said it's 30 degrees from the horizontal, so theta is 30. So 30 times sine 30. That is going to be 15. So VIY equals 15 meters a second. So we're going to say 0 is equal to 15 plus AY of t. So acceleration due to gravity is 10, right? No, wrong. Now, since I'm saying velocity is positive when I say 30, that means upward is positive, downward is negative. And so since the VIY, the vertical component of velocity, is always decreasing, we will understand that the acceleration will be negative. So we have minus 10 multiplied by the time. So we will throw 15